Hi guys, this is Vineet and I welcome you to this video. Today's video topic is tuning indexes using basic index suggestions in SQL Server. This is part 4 of this video series. Before we proceed ahead, I would request you guys to please go ahead and subscribe to my channel. There is a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding my upcoming and future videos. The reason I'm asking you to subscribe is because I don't want you to miss on any of the videos that I will be creating on the indexing topic in the coming 15 to 30 days. That's the reason I'm asking you to subscribe. So please go ahead and do so right away. I'm waiting. There's a subscribe button below this video. Hit on that button and follow the process. So guys, I hope you must have subscribed by now. So let's move ahead. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept, and if it's possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. Perform any exercises in your test and lab environments only. Do not touch any production environment or production databases. We would like to know your thoughts regarding our videos, so please do share in your comments and suggestions. Also, you can share in your stories as well. We eagerly wait for your comments and stories and would love to read the same. We have created some playlists for you to watch. Some of the popular SQL Server playlists are database design, tables, business continuity, indexing, performance tuning, integration services, and transact SQL. And if we talk about this video pertains to the SQL Server indexing category. And if we talk about the total number of videos posted on our channel, it's more than 240 videos at present. And the number of videos are growing at constant pace on a daily basis. My channel page link is given at the bottom of this slide. Also guys, the link to all these playlists and my channel page link is also given in the video description area. So please check out the video description area for this video. Let's come back to today's topic, which is tuning indexes using the missing index suggestions in SQL Server. And today we will be covering the topic how you can apply the missing index suggestions. In our previous video we have demonstrated you how you can find out the missing index suggestions using the estimated execution plans and by the use of DMVs and by the use of query store views. These three are the mechanism which can give you the idea about the missing indexes on the tables in your database. Today we will talk about, once you get the missing index suggestions, how to apply them. We will talk on this. Now let's cover this topic, which is apply missing index suggestions. Now whenever tuning non-cluster indexes, so whenever you tune the non-cluster indexes with missing index suggestions, before applying those suggestions we review the base table structure of the table, and then we carefully combine any indexes, and then we consider the key column order, and then we review included column suggestions. So these four are the main items whenever we apply any missing suggestions provided by the estimated execution plan or any other mechanisms. We review the base table structure, we combine some indexes, carefully combine some indexes I would say, and we will also take a look into the key column order, and we will review the included column suggestions as well. Now let's talk about the first topic, which is reviewing the base table structure. Now before creating any non-cluster indexes on a table based on missing index suggestions, we review the base table structure. So in the base table structure, what we review the table cluster index. So before applying or creating any non-cluster index, we review the cluster index already created on the table. And one way to check for cluster indexes by using the SP help index stored procedure. So let me demonstrate to you how you can use this stored procedure to find out about the existing indexes on a table. Let me execute this stored procedure against the person.address table in the AdventureWorks 2022 database. I've invoked SQL Server, waiting for it to open. So once it gets opened, I will show you how you can use this stored procedure. Alright, it's opened, and let me connect to the default instance of SQL Server. And we will use the AdventureWorks database. In my case, I've renamed that database to my AdventureWorks. For you, it will be AdventureWorks 2022 if you have installed it correctly. Now we will show you how to use the SP help index stored procedure to view the summary of indexes on the person.address table by executing the following statement. So you need to use the execute statement, and then you need to use the stored procedure, which is HP help index, SP help index, not HP help index, SP underscore help index, and then you specify the name of the object on which you want to know for which you want to know about the indexes. So in my case, the object is person.address, which is a table inside this database, my adventureworks. Let's see what all indexes are present on the person.address table. So it is saying that we are using the incorrect syntax. So let me verify whether it's incorrect. Doesn't look like it's incorrect. So let me see if we have person.address table. Syntax is looking okay to me. So we do have person.address table. Spellings are looking okay to me. Not sure why it is not executing. Now it is executed. I think I should have missed something. But yeah, this is the correct statement, and it has executed and listed out the index that are present on this table. Index description column is also there, which specify whether the index is clustered or a non-clustered index. So we basically review the index description column to figure out any cluster indexes. A table can only have one cluster index, and if a cluster index has been implemented for the table, then index description will contain the keyword clustered. So for example, we see a cluster index pk underscore address id is created on this person.address table. So this table has a single cluster index whose name is this pk underscore address id. Now if no cluster index is present, so in case this index was not present, right, the table is a heap. So if a cluster index is missing on any of the table, that table is known as heap. You may check out my video that I've created on heap during the earlier days when I started creating videos on indexing. So you can check out the indexing playlist. You will find the video on heap, what heaps are. So heaps are basically table without the cluster indexes. So without a cluster index present, a table is a heap. And in this case, we need to review if a table was intentionally created as a heap to solve a specific performance problem. So sometimes we do create a table as a heap or a table without a cluster index to reap some performance gains. So maybe sometimes we do not create a cluster index in order to reap some performance benefits. So you need to figure out why the cluster index is not present, whether it's for us to gain some performance benefits, or whether it's actually not created and it's essentially required. You need to figure out that. Now most table benefit from the cluster indexes. So if we talk about the cluster indexes, most table benefits from from creating the cluster indexes, and often tables are implemented as heaps by accident. So whenever a cluster index is not present on a table or a table is a heap, most of the times tables are implemented as heaps by accident. So sometime accidentally we miss on creating the cluster index on a table. Now you should consider implementing a cluster index based on your requirements. Yeah, in most of the cases it's essential. Now let's move on to second topic. So we are done with this demo using I've shown you how you can use the SP help index procedure on a table. Now let's talk about the second item. So first of all, we look at the base table structure. We look at the indexes of the table before implementing any non-cluster indexes on a table. We take a look at the existing indexes present on the table. Alright, so second topic is we review any missing indexes and existing indexes for any overlap. So what we do next is we review if any indexes are missing on the table, and we also check that whether any existing indexes can be combined together. Missing indexes may offer similar variations of non-cluster indexes on the same table and columns across the query. Missing indexes may also be similar to existing indexes on the table. For optimal performance, it is best to examine missing indexes and existing indexes for overlap and avoid creating duplicate indexes. Now let me summarize this statement. Basically, sometimes you get the missing index suggestions, right? For example, earlier I was executing a query. I can show you I had saved it. So this was the query I was executing, and I was creating an estimated execution plan for this using this button. And this plan was saying that I'm missing a particular index and it is asking me to create a non-cluster index on certain columns. So non-cluster index on person.address tables, and it is asking us to create a index on state province ID column, and it is also asking us to include the city and postal code column. You need to match up these missing index suggestions with the indexes already present on the table. So in this situation I had also used that, which table had I used here? In this situation, I have used person.address table. So in this case also it is asking us to create an index on the person.address table itself. So here I've joined two tables, person.address and person.business entity address, and it is only giving me suggestions to create a non-cluster index on the person.address table. So you need to match this missing index suggestions with the already present indexes on the table. So we already have here we see we already have a state province ID index already created on the table. So we don't think at this point we need another index, another non-cluster index on the state province ID. It's already a non-cluster index and the index key is set to state province ID, which I think is fine. So basically the missing index suggestion basically gives you variations of the index already present on the system, present on the table, I would say. So missing index may offer similar variations of non-cluster index on the same table and columns across queries. So here the missing index suggestion is almost the same. Here it is giving us suggestions to create an index on state province ID column. But if we take a look at the indexes already created on the table, we already have a index non-cluster index present on the state province ID column. Now let's take a look at next point. Here we have also found that missing indexes is similar to the existing index on the table. And for optimal performance, it is best to examine that missing indexes and existing indexes for overlaps. So here also the two indexes are overlapping, which is on the state province ID column. So here overlap is occurring between the missing index and already existing index. We shouldn't be creating duplicate index in this scenario. So we should ignore creating that missing index suggestion. Now let me take you through a demo where I will show you how you can script out existing indexes on the table. Let us show you how you can script out existing indexes on the table. So let's take you through a demo. So one way to examine the definition of existing indexes on a table is to script out the indexes with object explorer details. So basically we can script out indexes as well. So you need to expand the database and you need to expand the tables column, which is already expanded, and we need to expand the table for which you want to script out the indexes. So for example, in our case, if we want to script out the indexes created on the person.address table, you need to expand person.address table. Then you need to select the indexes folder. Now in the objects explorer details pane, it is not already open. So if the object explorer is not already open, you can open it through view menu as well. So there are two windows. One is object explorer, which is currently open in the background, and another window is object explorer details window. So let's open that. So here we have opened the object explorer details window. I am on the indexes column, right? And this window changes as per the item I have selected. So I have selected the indexes folder, and on the right hand side it is showing me details of that object explorer. It has 4 indexes on the right hand side showing up on the object explorer details window. Now we need to select all the indexes on the object explorer details panes with the shortcut Control A. So here we can do a Control A to select all the indexes, and we need to right click anywhere in the selected region and select the menu option script index as. So you need to right click over here and it gives you an option to script index as. Then we can choose create to, and we can use the new query editor window. So this option will script out the indexes as a query to a new query editor window. So this is the code to create all these 4 indexes. This is how you script out the code. So we are done with this practical, guys, and let's move on to the next topic where we review indexes and combine wherever possible for us. Once we get the list of indexes like this, like we got here, we basically review the indexes and combine them wherever possible. So let me write something out here. Now we review the missing index suggestions for a table as a group. So we take a look at all the indexes collectively instead of individually. So for example, here we take a look at all the 4 indexes collectively instead of taking them as individual indexes. We review the missing index suggestions for a table as a group along with the definitions of existing indexes. So if we take a look at SQL Server, if we take a look at this plan, and if we take a look at the XML plan, so here the execution plan is showing that we are missing 2 indexes. First missing index is this, which is missing on a person.address table, and it is asking us to create an index on state province ID. Second index it is asking us to create is on the first name column. so which is an inequality index. So it is offering here the two suggestions. So we should take all these missing indexes collectively, and we should take them as a group along with the definition of existing indexes. So existing indexes are given over here. So let me close the object export details. This is not required. And these are the existing indexes details. So we together take the missing indexes details as well as the existing indexes detail, or the definition of existing indexes on the table. We should review all of them together. And there is one point to remember. Now remember that when defining indexes on a table, generally equality columns should be put before the inequality columns. So we should always put the equality columns before the inequality columns, and together they should form the key of the index. So we should use both the equality and inequality columns together, but we should put equality columns before the inequality columns. And if we talk about the order, to determine an effective order for the equality columns, order them based on their selectivity in the where clause. Not in the where clause, but in the select clause. So we should order any equality columns on the basis of their selectivity. List the most selective columns first, which should be the leftmost column in the list. Unique columns are more selective, while columns with many repeating values are less selective. So this is also one of the criteria. So any unique columns should be very much selective compared to the columns with repeating values, which are most probably less selective. If we talk further, included columns should also be added to the create index statement. So we should take included columns as well whenever we are creating an index using the include clause. So we can use the include clause in the create index statement to include any columns, to take them as part of included columns. And the order of included columns, if we talk, does not affect query performance. So the order of columns in the included clause doesn't matter. It does not affect the query performance. Therefore, when combining indexes, included columns might be combined without worrying about the order. Now let's take an example of person.address table. For example, let's take person.address table with an existing index on the key column state province ID. So if we take a look at the table, this person.address table has a non-cluster index created on the state province ID column. So let's take this as an example. You might see missing index recommendations for the person.address table for the following columns. So whenever we take a look at missing index suggestion for this table, we will come across some of the suggestions, missing index suggestions, and one of the suggestion. So first, it provides the equality filters for state, province, ID, and city. So first, it provides the equality filters for state, province, ID, and city. Then it can also sometimes provide you equality filters for state, province, ID, and city, and include the postal code column. So here it has not provided, okay, it has provided us include suggestions here. So in the first index suggestion, it is asking us to create an index on person.address table with an equality filter, and this index should be created on the state, province, ID column, and it is asking us to include the city and postal code column. And second suggestion, it is providing us to create an index on person.person table, and it's providing us an inequality filter, and it is asking us to create a index on first name column. So these are two of the variations sometimes we encounter. Our variation is slightly different than the one I mentioned over here. So it is providing us an equality filter for state, province, ID, and it is also asking us to include the city and postal code columns. Now modifying the existing index. So if we take a look at the existing index over here, right, it is a non-cluster primary non-cluster index on a state, province, ID column. So this is the index ix address state, province, ID. Modifying the existing index to match the second recommendation from, so if we want to modify the existing index to match the second recommendation, an index with keys on state provenance ID. So if we go by missing index suggestion, which is this, where it is showing us equality filters on two columns, state province and ID, and if we want to provide this, apply this suggestion on the existing index. So modify, if we want to modify the existing index to match the second recommendation, which is this, an index with keys on state province ID column and city column, and including the postal code column, including the postal code, would likely satisfy the queries that generated both index suggestions. So both for these two suggestions, we can create and combine and create a single index, and we can modify an existing index where we will include the state, province ID and city as a part of key, and we can use the include column, postal code as the include column, which will satisfy our purpose. And if we talk about this combining indexes or index tuning, trade-offs are common in index tuning. So if we talk about the index tuning process, trade-offs here are common, and it is likely that for many data sets, the city column is more selective than the state province ID column. So for certain data set, it may be possible that city column is more selective for our index than the state province ID column. However, if our existing index on state province ID is heavily used, so if our existing index on the state province ID column is heavily used and other requests largely search on both state province ID and city, it is lower overhead for the database in general to have a single index with both the columns in the key. So it is better if we can take both state, province ID and city columns as a part of key if search is made on both the columns instead of just state, province ID. So there should be less overhead on the database in general to have a single index with both the columns in the key leading on state, province ID, although it is not the most selective column. Alright. Now if we talk about indexes, they can be modified in multiple ways to modify indexes. Let's talk about this, how we can modify the indexes. There are multiple ways to do so. So we talk about the first way. You can use the create index statement with the drop existing option to drop the existing index. Second way is to rename the index. You might wish to rename the index. In this way you can modify the indexes following the modification. So if you modify an index, you might want to rename that index after the modifications so that the name still accurately describes the index definition depending upon your naming convention. Alright. Another way to modify the index is you can use the drop index statement to drop the index followed by the create index statement. This way you can modify the index as well. So these three are the most common ways through which you can modify the indexes. The order of the index keys matter when combining the index suggestions. So whenever we combine the index suggestions, the order of the index key matters the most. For example, city as a leading column is different from state, province, ID as a leading column. So both the cases are different. Whenever you are creating indexes, so when creating indexes, especially I'm talking about the non-cluster indexes here. So when creating indexes, consider using the online index operations in which the index remains available even though you are recreating it. So always use the online index creation operation whenever they are available for the non-cluster indexes. The cluster indexes cannot be rebuilt in the online mode. It should always be rebuilt in the offline mode. When indexes can dramatically improve query performance in some cases, indexes also have overhead and management cost. So while indexes, if we talk about, can dramatically improve query performance, in some cases, indexes also carry the overhead and management costs as well. Now let me talk about how you can verify that your index change is successful. How to verify that. So suppose in case you make a change to the index and you want to see whether your index is successful or not, this should be your fourth operation. Apart from the earlier three were, you need to review the base table structure You need to review missing indexes and existing indexes for overlap. Then you review the indexes and combine them where possible. Then the next item is I've discussed about the ways to modify indexes, but the last and fourth item is verify if your index change is successful. And basically this point is very important. So it's important to confirm. So it is important to confirm if your index changes have been successful. Is the query optimizer, which is to basically see if your query optimizer using your indexes. So the best way to determine whether your indexes are being used, to take a look at the query execution plan. You can take a look at the actual execution plan of the query to determine whether indexes are being used. And one way to validate your index changes is to use query store. So we can use query store as well to identify query with missing indexes. In our earlier video, part 3, we talked about how you can query the query store to view information about the missing indexes or missing index requests. And you should note the query ID for these queries if any of the queries are missing index. And you can use the tracked queries view in query store to check if execution plans have changed for a query and if the optimizer is using your new and modified index. Alright guys, we are done with this section. Later on we will show you how to use the query store practically when we will start making the videos on query store explicitly. For now we are just giving the theoretical description over here. So guys, we are done with this video. In today's video we have talked about how you can apply the missing index suggestions. Under that we have talked about how you can review the base table structure. So there are 4 items that you need to perform before applying any missing index suggestions. You need to review the base table structure. You need to carefully combine the indexes. You need to consider the key column order. You need to review the included column suggestions as well. Now we elaborated on how you can review the base table structure, and we have also shown you demo on how you can use the SP help index stored procedure to view the indexes on the table. And then we elaborated on how you can review missing indexes and existing indexes for any overlaps, basically comparing them, the missing indexes and the existing indexes. Then we have shown you a demo on how you can script out existing indexes on the table. Then we elaborated on how you can review indexes and combine 2 indexes wherever possible. Then we elaborated on ways to modify the indexes, and then we talked about verify if your index change is successful by looking at the query store views. And later on we will show you some practicals as well, but that we will cover in the query store section when we start making videos on them. So guys, I hope you like the content of this video. If you really like the content, please click on the like button below this video. And guys, if you are new to this channel, or if you are an old viewer who are watching my videos from quite some time and have not yet subscribed to the channel, please go ahead and do so. There is a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my upcoming and future videos. The reason I am asking you to subscribe is because I will be creating many more videos on indexes in the upcoming 15 to 30 days. So I don't want you to miss on any of these videos. So if you subscribe to my channel, you will get the timely notifications, so that you should be able to view my videos in real time as soon as they get released, or you may watch it as per your convenience as well, but yeah, at least you will get the alerts. So that's why I'm asking you to subscribe. So please go ahead and subscribe right away. I'm giving you 5 seconds. There's a subscribe button below this video. Click on that button and follow the process. So guys, I hope you must have subscribed by now. Guys, do share in your comments and suggestions. Also share in your stories as well. We eagerly wait for your comments and stories and would love to read the same. And also guys, if you have a good network of friends who work in SQL Server domain, then please, you may share my videos with them. There's a share button below my videos. Each and every video there's a share button below that. Use that share button to share videos with your friends on any of the social media platforms. And you may also ask your friends to subscribe to my channel. This is the help I required from your end. And I thank you so much for your time on this video today, and you have a wonderful day ahead.